All right, let's talk about some of these exponent rules. You've seen some of these before, but we need to do a quick review before we do some problems practicing our exponent rules so we can just be grandmasters at them. The first exponent rule you'll see is x to the 0 equals 1. And that just simply means any number at all, if taken to the 0 power, will always equal 1. And that's a kind of confusing one for some people because they're just like, that doesn't really make sense. And really the best way to describe this is by how we came up with this rule is by coming up with a pattern. The 0 exponent follows a pattern, and that's really why it makes sense. So if I were to write this out the long way, 2, and so here's an example just kind of showing how it works. 2 to the 4th just means 2 times 2 times 2 times 2. My base number is being repeated 4 times. And that is going to equal, well, 2 times 2 times 2 times 2. 4 times 4 is 16. 2 to the 3rd is going to be 8. 2 to the 2nd is going to be 4. 2 to the 1st is just 1, 2, and that's 2. Now notice what's happening with each of my answers here. The pattern that's happening is I'm doing 16 divided by 2 becomes 8. 8 divided by 2 becomes 4. 4 divided by 2 becomes 2. So the next logical pattern would be 2 divided by 2 becomes 1. So that's kind of how this pattern works, why 2 to the 0 equals 1. And then just a preview of a negative exponent. The next pattern here, 1 divided by 2 is 1/2. And so that brings us to the negative exponent rule, which we'll see in a bit. Anything to the negative exponent flips that down into the denominator, basically flips it. So that's an explanation of why that rule is the way it is, just because it fits the pattern of exponents. The next one, when we are multiplying anything with the same base, we're adding our exponents. And again, I've had a lot of kids go, okay, I forget what rule it is. If you can know why the rule works, you can recreate it. So here's an example. 2 to the 3rd times 2 to the 5th. Same base, which is important. If you write this out the long way, you can recreate the rule and you don't have to memorize it. 2 to the 3rd is simply 2 times 2 times 2. 2 to the 5th is 5 2s, 1, 2, 3, 4, 5. And I can, because this is all multiplication, I can multiply them any way I want. Basically, I have how many 2's do I have? I have 8 2's. And so what do? Oh, if I have the same base, I can add my exponents. So that's a simple way of recreating the rule in case you forget it. The second rule is when you're taking an exponent to a power. People always mess up these ones. So again, let's recreate the rule so that you can recreate it whenever you need to. So if I have 2 to the 3rd power and then I'm taking that whole thing to the 5th power, oh, I'm going to be writing a lot here. This simply means I have this amount to the 5th. So I have 2 to the 3rd times 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 2 to the 3rd. 1, 2, 3, 4, 5 groups of 2 to the 3rd. And if I were to write this out again the long way, this would, oh, good gravy. This would be 2 times 2 times 2 times 2 times 2 times 2. You are getting the idea. And my last group. And how many 2's do I have? I can count them all up. I have 15 of them. This is repeated 15 times. So that's my reminder that when I'm taking it to a power, I am multiplying my powers, and that's why that rule works. Next one, when we are dividing, when we have the same base, we subtract our exponents. And why does that work? Again, if you understand why the rule works, you can recreate it whenever you need to. So 2 to the 5th divided by 2 to the 3rd, same base. If I were to write this out the long way, in my numerator I have 5 2's. In my denominator, oops, why did I make that one a 3? I have 3 2's. And then I can just simplify. 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. I am left with 2 2's on the top and nothing on the bottom. So that's a reminder that 5 minus 3 is 2. That's where that one goes. And if you have them flipped, it's the exact same principle, but if you have more exponents on the bottom than you do on the top, you're going to have more left over on the bottom. So if we write this out the long way, here we go. 3 2's and 5 2's. 2 divided by 2, 2 divided by 2, 2 divided by 2. I'm left over with 1 in my numerator. So I have 1 over 2 squared. And we talked about negative exponents. If you have an exponent in the bottom in your denominator, you can just write it as a negative exponent. So that is 2 to the negative 2 power. The negative exponent flips it from denominator to numerator. So that's why that rule works. And here we go, our negative exponent rule. If you have a negative exponent, basically it flips it from numerator to denominator or denominator to numerator. So if I have 2 to the negative 3rd power, okay, this is technically over 1. All this does is switches this, so now I have 1 over 2 to the positive 3rd. And vice versa, if I have 1 over 2 to the negative 3rd here, I want to rewrite this as a positive exponent that flips it from denominator to numerator, and I would switch my negative to a positive. So a negative exponent just switches the number from numerator to denominator or vice versa. And then, last but not least, when we have a base taken to a fractional exponent, the numerator is your power and your denominator is your radical right there, or your root, what you could call it. And you can write it either of these two ways. You can have your power inside of your radical, or you can have your radical inside of your power. Both of them will work, kind of depends on which way is easiest for whatever problem you're doing. So for example, 4 to the 1/2 power. Another way of writing that could be 4 to the 1st power, and then I'm going to take the square root of that. I normally wouldn't write that. I mean, I would just normally write the square root of 4. Technically, I wouldn't even write the square root. I would just write the square root of 4, which is 2. But I could write it that way. And then, or I could write it, I could write the square root of 4, and then I could take that whole thing to the 1st power. Both of those are saying the exact same thing. And then if you have 5 to the 4 halves, we know that this is just 5 squared, but a lot of times we can manipulate things different ways, and that's kind of nice to know the rules. I could write this as 5 to the 4th power, and then I'm going to take the square root of it. Or I could take the square root of it first. I could take the square root of 5, and then I'm going to take that to the 4th power. These are the same thing. I can do either of those things. So that is a review of your exponent rules and why they work. And let's go ahead and practice Pizzazz page 67. And I'm going to do 7 through 11 as example problems together, just so that we're all on the same page. So, let's switch this way. All right, so number 7 on Pizzazz page 67 is a squared plus b plus a squared plus b squared plus b. This is just a simple reminder that we need to combine like terms. So all of my a squareds are like terms. This is a positive a squared. So a squared and a squared is 2a squared. They're done. I'm going to combine my b squareds next. This is a positive b squared. That one's done. And then I'm going to combine my b's. So that's a positive b and a positive b. That's positive 2b. So that is my answer for number 7. 2a squared plus b squared plus 2b, and there's no other way to combine that anymore. That's just all we can do. Number 8, I have negative 2a to the third b to the fourth power. I'm going to write this out the long way, and then I'm going to do it kind of a shortcut, but the shortcut won't work unless you understand how to do it the long way. This fourth power means this whole thing is being multiplied by itself 4 times. So I would get 2a to the third b times negative 2a to the third b times negative 2a to the third b times negative 2a to the third b. Whew! And from there I can go, well, I'm going to multiply my coefficients. So negative 2 times negative 2 times negative 2 times negative 2. I have an even number of negatives, so I know I'm going to get a positive. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. My coefficient will be 16. a to the third times a to the third times a to the third times a to the third. Well, I have 3 here, 6, 9, and 12. So I have 12 a's that are being multiplied. And then b's, I have 1, 2, 3, 4. So I have b to the fourth. So that's kind of doing it the long way. You could go ahead and simplify this and go straight from here to here. If you remember that negative 2 to the fourth power is negative 2 times negative 2 times negative 2 times negative 2, that's 16. a to the third to the fourth power, that's taking a power to a power, that's multiplying. So 3 times 4 is 12. And b to a power, this is technically a 1, so 1 times 4 is 4. So you could go straight from here to here. Number 9 is a squared times 6a to the third b times ab to the fifth. I have all multiplication, so I'm going to deal with my number first. I have no number other than 6, so my coefficient will be 6. Now I'm going to deal with my a's. All I have is multiplication, so my rule for that was I am adding the exponent. So I have 2 here, 3 here, and 1 here. 2 plus 3 plus 1 is 6, so a to the 6. Now I'm going to take care of my b's. I have 1 here and 5 here. I'm going to add them. 1 plus 5 is 6. So 6a to the 6th, b to the 6th. Lots of 6's. All right, going to go on to number 10. 10 is 4ab to the third times negative 5b to the 6th times 2a squared. All right, first thing, again, no, I'm not taking anything to a power, it's just all straight multiplication. So I'm going to start with my numbers. So 4 times negative 5 times 2. What am I going to do? Let's see, 4 times 2 is 8. 8 times negative 5 is negative 40. Now I'm going to multiply my a's. I have 1a here, no a's, and 2 a's. So 1 plus 2 is 3. And now I'll do my b's. I have 3 b's, 6 b's, and no b's. So 3 and 6 give me a total of 9. So negative 40, a to the third, b to the 9th. And let's go ahead and do number 11, where we have a bit of multiplication and subtraction all in one problem. Okay, we have 3a to the fourth b times 5ab squared minus, oh, I'm going to have to write smaller. A to the fourth b squared times 9b. Okay. Well, I'm getting messy. That annoys me. All right, in this case, I'm going to have to figure out this term and this term separately. So let's do the first term. 3 times 5, 15. A to the fourth and a to the first, that gives me 5 a's. B to the first and b to the second, that gives me 3 b's. So that's my first term. minus, now I'm going to figure out this whole term. I have 1 times 9, which is 9. A to the 5th, just a to the 5th. B to the 2nd, and b, which is b to the 3rd. Now the only way I can subtract these two terms is if they are like terms. So I have to take a look at my variables. I have a to the 5th, b to the 3rd, and both of them, they're like terms, so therefore I can combine like terms. 15 minus 9 is 6. And then I'm going to end with my variables. If these were not like terms, let's say that this was just b, I couldn't do anything more. I would just have to leave it as that. But since they are like terms, I can go one step further and combine them. And go ahead and finish page 67, get practice at those rules and get faster and more accurate.